Okay, good morning, everyone. Thank you, Vladislav, for inviting me to your workshop. I'm honored to be here and pleased to share my academic and research experience with you. My talk is much more down to earth, focusing on introductory education in modeling and simulation. SolidWorks plays a central role in modern engineering education, not only as CAD system, but as a platform for developing engineering thinking. At RTU, the focus is on using SolidWorks to connect spatial reasoning, modeling, drawing, production, simulation, and decision making, preparing students for real industrial workflows. This presentation outlines how academic training can be efficiently aligned with industry expectations and certification pathways. When we talk about SolidWorks in education, it is important to move beyond the idea of teaching a software tool. In modern engineering programs, SolidWorks serves as a foundation for developing engineering thinking, not just creating geometry. SolidWorks, serious enough for engineering, friendly enough for Latvian education budget. How to forward? Oh, got lost control of. Next slide. Okay. Current engineering SolidWorks performs like BIM, using a single shared model for real-time cooperation, coordinated updates and conflict detection, what engineers generally call PLM, product lifecycle management. Concurrent the widespread adoption of practical application of PLM and BIM models across engineering disciplines will only streamline design and collaboration, but will also fundamentally shape how products are developed, managed, and brought to market, ultimately defining the future of industry. At RTU, we use SolidWorks to introduce students to the cause and effect relationship between design decisions and real-world performance. Every modeling choice, dimensions, constraints, symmetry, or simplifications has consequences later in analysis, manufacturing, or operation. Another key reason for using SolidWorks is continuity. The same model created in a basic CAD course can later be reused for structural analysis, flow simulation, and parametric studies. This allows students to understand that engineering is not a sequence of isolated subjects, but a connected workflow where modeling, simulation, and validation are tightly linked. Finally, SolidWorks is widely used in local industry, which makes it an effective bridge between academic and real engineering practice. Students not only learning concepts, they are learning them in an environment they are likely to encounter again in their professional careers. After explaining why SolidWorks is important, the next question is how it is actually applied in the curriculum. Here I show my flowchart of two of my courses where SolidWorks is introduced early, one of which was enhanced with European funding. I expect it to be reinforced across multiple study courses and levels, rather than being confined to a single standalone course. The introductory overview course is offered to about 200 students each year across 6 study programs. Students first encounter fundamentals of engineering graphics and the basics of SOLIDWORKS. In the advanced course, the focus is on parametric part modeling, assemblies, and documentation. Advanced SOLIDWORKS I deliver to 60 students. And this course follows detailed prerequisite course on engineering graphics. And here students, along with SOLIDWORKS, progress to learn assembly, structure, and design intent, proper use of mates and constraints, and engineering drawing that follows standards and manufacturing logic. A key transition happens when students move from simply creating geometry to understanding why a model is built in a certain way. Here emphasis is placed on model robustness, clear feature structure, and future use of the model for simulation and modification. This approach intentionally prepares students for later courses where the same SOLIDWORKS models are not rebuilt from scratch but extended into analysis and simulation tasks. In this way, SOLIDWORKS becomes a continuous learning platform rather than one-time software skill. I use the following teaching method. Practical exercises are conducted simultaneously in 2 computer labs of 30 seats each. As RTU does not have a single lab with 80 to 100 seats, unlike a friend of mine, a professor in Germany. I present short theoretical concepts in PowerPoint, stream them to the second lab via Zoom, and record them for later review. Both labs have 2 large screens, and in the second lab, a colleague assists me. I use flipped classroom approach. The students are required to watch instructional videos before the session and then work independently in class and on exercises. I manage the computers on both labs using Vayon software and taking control whenever a student encounters a problem to demonstrate the solution. Usually, if one has the question, several others do too. Then I take the control of the student's screen and share it on both classes, demonstrating the solution without wasting time to walk to the student's seat. Something is wrong with so here is the class I showed before, and somehow the synchronization doesn't work well for me. Sorry. Final goal for the task they have to master is to prove the control over the design intent. In the first easiest step, students are are given typically 4 answers, and they have to choose from the 4 answers the correct one. Those who are not patient may submit the solution, but they just get partial credit. For For the serious studies, they need to work constantly on this problem in several steps to solve the problem by themselves. The goal is to let the students practice to master design intent by themselves. And Moodle quiz serves purely for self-assessment. The teacher is built into this Moodle system. At RTU, SolidWorks is primarily used for learning and concept understanding. Models are simplified, assumptions are discussed, and results demonstrate just basic principles. In industry, models are more complex and must be robust, reusable, and clearly documented to support simulation, manufacturing, and decision-making. Historically, industry representatives have sometimes complained about our graduates that they have poor skills in interpreting mechanical engineering drawings. Partially, it was caused by decades of limited funding for PCs and CAD software, as well as university curriculum changes after Latvia regained independence. 10 years ago, we still held so-called CAD Olympic contests for the students to challenge them to more industry-like tasks. But today, such contests are too complex to run them at all. Highlighting these differences in studies helps students bridge the gap between education and real industrial workflows. To extend the impact beyond the university, the current course is being duplicated on an open MOOC platform. Its purpose is to lower the entry barrier, spark interest, and guide motivated learners toward more advanced lifelong learning programs. At the university, they have to subscribe for these later. And in recent years, RTU has organized free introductory courses with several EuroCC project initiatives. These courses are not only focused on CAD skills, but also on motivating engineers from the industry and students to use HPC resources for large-scale simulation tasks. Some industry-inspired examples from these activities I will demonstrate in my lecture tomorrow. One practical way to align academic training with industry expectations is through SolidWorks certification. Certifications like CSWA and CSWP and simulations-focused exams provide a clear, externally validated benchmark of skills. There is a list of 14 different exams available to RTU students thanks to the current license subscription. In this sense, certification becomes not just a personal achievement, but a bridge between open education, university studies, and industry needs. The illustrated certification track shows the recommended sequence on how to form a clear skills development pathway. For students, certification structures learning, builds confidence, and creates a recognizable reference for employees. In our course, certification is positioned not as an obligation, but as an opportunity. At the end of the course, students may take the certification exam free of charge And this serves as a carrot rather than stick, which significantly improves motivation and engagement in compulsory university course. From education perspective, certification also benefits instructors by providing a clear target competence level, objective feedback on learning outcomes, and a shared language when discussing skills with industry partners. A straightforward practical approach to parametric feature-based modeling. I was surprised that industry representatives who already work with SOLIDWORKS daily are still willing to take the time to prepare for CSWA certification exam. Here you can see the schedule of these courses which they took after their working hours and took this certification exam when they joined lifelong learning course at the university. To conclude, I would like to return to the main message of this presentation. SOLIDWORKS becomes truly valuable in engineering education when it is used not only to create geometry, but to support reasoning, analysis, and decision-making. By integrating modeling, simulation, and certification into the curriculum, we can better prepare students for real industrial workflows. From an educational perspective, the key is consistency. Consistent tools, consistent methodology, and consistent expectations aligned with industry practice. Thank you, and I look forward for continuing this discussion tomorrow from more technical, hands-on perspective. Sorry for technical problems while switching these slides. There was some problem with my Zoom.
Thanks a lot. We are very appreciate your talk, and this is again what we need for understanding for beginning of work for next talks. And maybe some questions, and just to be sure I understand correctly. In Riga Technical University, you have a main course for students, and also this course is available for not students as well. Is it right?
That's correct. Yes, they are organized some within other projects, some courses, shorter course and extended course like you saw before, 16 weeks, or just 4 days. Most important is that these courses are free of charge.
Even for not students. So
yes, that's correct. That's correct. But they usually are organized just once a year for interest from industry.
And you show a lot of industry representatives also willing to join these courses even at evening times after work. Could you
yes, that's correct. That was my surprise. I was wondering, they already have work. They work with SOLIDWORKS. And my question was, why do you need this certification? I understood that students need this certification when they are looking for their next job, so they can show that they have some practical skills. But those who are already working, that was my surprise.
Entrepreneurs who are hiring people, are they appreciate these certificates? So we're asking about certificates for people who are looking for work. So how important for like a potential worker or engineer to have this certificate? So how it helps to rise salary or find a job?
Yeah, that's an interesting question to work on this. I have not studied about this. Sorry.
Okay, but thanks a lot. Thanks again